need to dynamically modify your AI's toolset at runtime without complex workarounds or server restarts. You'll see how FastMCP lets you remove tools programmatically with a single line of code, keeping your AI's capabilities perfectly aligned with your application's current needs. We'll create a simple calculator tool, then demonstrate its complete removal from the server's available tools, all while the server continues running. From FastMCP, import FastMCP. MCP equals FastMCP. Name equals dynamic tool server. At MCP, tool. Def calculate sum A, int B, int. Add two numbers together. Return a plus B. MCP, remove tool, calculate sum. This demonstrates the dynamic tool registration pattern for AI-integrated systems. The Decorator-based approach transforms ordinary Python functions into AI-callable tools while maintaining clean separation between business logic and RPC infrastructure. What makes this distinctive is how it combines Python's native type system with automatic schema generation, eliminating the need for manual API definitions. The pattern works by treating tool registration as a declarative process rather than an imperative one. When you decorate a function with @MCP tool, the framework inspects its signature, generates validation schemas from type hints, and registers it as a callable endpoint, all without modifying your function's implementation. This enables runtime flexibility, where tools can be added, removed, or modified programmatically while the server is running, with changes automatically propagated to connected clients. This approach solves the dual problems of RPC boilerplate and AI integration complexity. By handling serialization, validation, and transport automatically, it lets you focus on core logic while maintaining type safety and discoverability. The trade-off is framework dependency, but the benefit is rapid development of AI-extended systems where tools can evolve dynamically without server restarts or client-side updates. Let's break it down line by line. From FastMCP, import FastMCP. This imports FastMCP, the core class for creating AI-callable tools. It bridges Python functions to AI models, enabling dynamic tool registration and execution. MCP equals FastMCP. Name equals dynamic tool server. This instantiates the FastMCP server with the identifier dynamic tool server. The name parameter distinguishes this instance for logging and connection management, critical when running multiple MCP servers in the same environment. At MCP, tool. Def calculate sum A, int B, int. Add two numbers together. The @MCP tool decorator registers this function as an AI callable tool. FastMCP uses the type hints and docstring to auto-generate the tool schema, ensuring the AI understands the input-output contract. This is the standard pattern for exposing Python functions to AI models in FastMCP. Return a plus B. This implements the tool's core logic by returning the sum of inputs, A and B. The simplicity ensures predictable behavior, while the type hints and docstring, defined earlier, provide the AI with a complete schema for calling this function. MCP, remove tool, calculate sum. This dynamically unregisters the calculate sum tool from FastMCP's available tools. Useful for runtime modifications when you need to disable or replace tools without restarting the server. The operation is immediate and idempotent, calling it multiple times has no side effects. Dynamic tool management. The remove tool method demonstrates FastMCP's runtime flexibility, allowing tools to be unregistered while the server runs without restart. Removing a tool doesn't delete the underlying function, just its exposure to clients through the MCP protocol. This enables hot reloading of toolsets in production environments.
The tool that vanishes from the registry remains everywhere in the code.